Statistics can be misleading and require careful examination. Correlation does not necessarily imply causation. National Electrical Code, or NEC, changes should be based on sound evidence and avoid overreactions to coincidental events. The National Fire Protection Association, or NFPA, has observed 7 suicides from hotel balconies during its conventions. A reasonable person might conclude there is a higher probability of suicides during NFPA events. However, it is important to note that these events are isolated and occurred simply by coincidence. The NEC should not impose restrictions based on coincidental events. Careful analysis of all relevant data is crucial to avoid unwarranted regulations. Statistics must be interpreted in context and with consideration for potential biases. The anecdote about the suicides at the NFPA conventions highlights the importance of critically examining statistics and avoiding hasty conclusions. By carefully considering all the facts, decisions can be made and prevent unnecessary overreactions that may have unintended consequences. When interpreting statistics, it's vital to distinguish between correlation and causation. Just because 2 events occur together doesn't mean one causes the other. Understanding potential biases is also crucial. Statistics can be skewed or misinterpreted to support a particular viewpoint, so you should always consider the source of the data and any potential conflicts of interest. When considering changes to codes or regulations, it's essential to base decisions on sound evidence, not just coincidences. For example, if a series of electrical incidents occur in a specific type of building, it doesn't necessarily mean that a new regulation targeting that building type is warranted. Instead, a thorough investigation should be conducted to identify the underlying causes of the incidents. This investigation might reveal that the incidents were due to faulty equipment or improper installation practices, rather than any inherent flaw in the building design. In such cases, the solution might involve stricter enforcement of existing codes or improved training for electricians, rather than a new regulation that could impose unnecessary costs and burdens on building owners. The NEC is a comprehensive set of standards designed to ensure the safe installation of electrical wiring and equipment. It's updated every 3 years to reflect the latest technological advancements and address emerging safety concerns. The process of developing and revising the NEC involves input from a wide range of stakeholders, including electrical engineers, contractors, manufacturers, and inspectors. The NEC is organized into chapters, articles, and sections, each addressing a specific aspect of electrical safety. For example, Article 210. 12 covers arc full circuit interrupters, or SIs, which are designed to protect against electrical fires caused by arcing faults. Article 230 covers service entrances, which are the point where electrical power enters a building. Article 250 covers grounding and bonding, which are essential for preventing electrical shock hazards. The NEC also includes numerous tables and examples to help electricians and inspectors apply the code correctly. For example, Table 310.16 provides ampacity ratings for various types of conductors based on their size, insulation, and ambient temperature. Example D3 provides a step-by-step calculation for determining the minimum size of service entrance conductors for a dwelling unit. When interpreting and applying the NEC, it's important to consider the specific context of the installation. The code is not intended to be a rigid set of rules that must be followed blindly. Instead, it's a set of guidelines that should be applied with sound engineering judgment. In some cases, it may be necessary to deviate from the strict letter of the code in order to achieve a safer or more practical installation. However, any such deviation should be carefully documented and justified. The NEC is constantly evolving to keep pace with changes in technology and industry practices. The code-making process is open and transparent, and all interested parties are encouraged to participate. By working together, we can ensure that the NEC continues to provide a high level of safety for electrical installations. Changes to the NEC are proposed and reviewed on a 3-year cycle. Any individual or organization can submit a proposal to change the code. These proposals are then reviewed by code-making panels, which are composed of experts in various fields of electrical safety. The code-making panels consider all comments and suggestions before making a final decision on whether to accept or reject a proposal. The NEC is not a law in itself, but it is often adopted by state and local governments as part of their building codes. When a jurisdiction adopts the NEC, it becomes legally binding within that jurisdiction. Therefore, it's important for electricians and contractors to be familiar with the latest version of the NEC and any local amendments that may be in effect. Continuing education is essential for staying up to date on the NEC. There are many organizations that offer training courses and seminars on the code. These courses can help electricians and contractors understand the latest changes to the code and how to apply them in practice. The NEC also includes provisions for special occupancies, such as healthcare facilities, hazardous locations, and marinas. These special occupancies have unique electrical safety requirements that are not covered in the general rules of the code. For example, healthcare facilities must have redundant power systems to ensure that critical equipment continues to operate in the event of a power outage. Hazardous locations, such as chemical plants and refineries, must have explosion-proof electrical equipment to prevent fires and explosions. Marinas must have ground fault protection to prevent electric shock hazards near the water. The NEC also includes provisions for renewable energy systems such as solar photovoltaic or PV systems and wind turbines. These systems are becoming increasingly common, and the NEC is constantly evolving to address the unique electrical safety challenges they present. For example, the NEC includes requirements for disconnecting means, overcurrent protection, and grounding of solar PV systems. The NEC is a complex and comprehensive document, but it is essential for ensuring the safe installation of electrical wiring and equipment. By understanding the principles behind the code and staying up to date on the latest changes, electricians and contractors can help to prevent electrical hazards and protect people and property from harm. The NEC provides specific guidelines for wiring different types of buildings, from residential homes to commercial buildings and industrial facilities. It covers various aspects of electrical installations, including wiring methods, overcurrent protection, grounding, and equipment installation. The code also addresses the use of different types of electrical equipment, such as motors, transformers, and generators. It specifies the requirements for the installation, operation, and maintenance of this equipment to ensure safety and reliability. The NEC is constantly being revised and updated to reflect changes in technology, industry practices, and safety standards. The code-making process involves a rigorous review of proposed changes by a committee of experts who consider input from various stakeholders, including electrical engineers, contractors, manufacturers, and regulatory agencies. The NEC also provides guidance in the selection and use of electrical materials and equipment. It specifies the types of materials that are suitable for different applications, as well as the installation requirements for various types of equipment. The code also addresses the issue of product safety and requires that all electrical products be listed by a recognized testing laboratory, such as Underwriters Laboratories, or all. The NEC also includes provisions for emergency systems, such as backup generators and uninterruptible power supplies, or UPSs. These systems are designed to provide power to critical loads in the event of a power outage. The code specifies the requirements for the installation, operation, and maintenance of these systems to ensure that they are reliable and effective. The NEC is an essential resource for anyone involved in the design, installation, or inspection of electrical systems. It provides a comprehensive set of guidelines and standards that can help to ensure safety and prevent electrical hazards. The code is constantly evolving, and it is important to stay up to date on the latest changes to ensure that electrical systems are installed in accordance with the most current safety standards. The anecdote about the suicides at NFPA convention serves as a reminder to critically examine statistics and avoid hasty conclusions. In the context of electrical safety, this means carefully considering all the relevant data and factors before making decisions about code changes or regulations. It also means being aware of the potential for biases and misinterpretations in statistical data. By taking a thoughtful and evidence-based approach, we can make informed decisions that promote electrical safety without imposing unnecessary burdens or restrictions. The goal is to prevent electrical hazards and protect people and property from harm. The NEC is an important tool in achieving this goal, but it must be used wisely and with a critical eye towards the potential for misleading statistics and unintended consequences. The NEC addresses the proper installation and use of ground fault circuit interrupters, or GFCIs, which are designed to protect people from electric shock hazards. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas, where there is a high risk of contact with water. The NEC specifies the requirements for the installation and testing of GFCIs to ensure that they are functioning properly. It also addresses the use of arc fault circuit interrupters, or AFCIs, which are designed to protect against electrical fires caused by arcing faults. AFCIs are required in many locations, such as bedrooms, where there is a high risk of fire. The NEC specifies the requirements for the installation and testing of AFCIs to ensure that they are functioning properly.